What if Earth's magnetic field reversed? Imagine an invisible force, a silent guardian constantly at work, shielding our planet from the harsh realities of space. This is Earth's magnetic field, a vital, unseen barrier that makes life as we know it possible. It's a protective bubble deflecting deadly solar radiation and preserving our atmosphere. But what if this shield faltered? What if its poles, north and south, decided to swap places? This isn't a scenario from science fiction. It's a phenomenon known as a magnetic field reversal, and it has happened many times throughout Earth's long history. Deep within our planet, far beneath the surface, lies the engine of this incredible shield. Earth's outer core, a vast ocean of swirling molten iron and nickel, is in constant motion. This dynamic movement generates powerful electric currents. These currents, in turn, create a colossal magnetic field, effectively turning our planet into a giant bar magnet. This process is often referred to as the geodynamo. The resulting magnetic field extends far into space, forming what we call the magnetosphere. This magnetosphere acts as a formidable barrier, deflecting the relentless stream of charged particles known as the solar wind. Without this protective bubble, the solar wind would strip away our atmosphere over time, making Earth uninhabitable. It is absolutely essential for safeguarding our atmosphere and enabling the rich diversity of life we see today. The idea of Earth's magnetic poles flipping might seem unsettling, but geological records confirm it's a natural recurring event. Our planet's magnetic poles have indeed swapped positions numerous times over geological timescales. These reversals are not anomalies. They are a fundamental part of Earth's dynamic history. The most recent major reversal, known as the Brunhes-Matuyama reversal, occurred approximately 780,000 years ago. Scientists uncover evidence of these ancient flips by studying ancient lava flows. As molten rock cools and solidifies, tiny iron particles within it align themselves with Earth's magnetic field at that precise moment, effectively freezing a record of its direction. When these rocks are examined, they reveal periods where the magnetic north was where the geographic south is today, and vice versa. These reversals are a natural, albeit slow, part of Earth's geological history. However, a modern reversal would present far more complex challenges due to our reliance on advanced technology. A magnetic flip is not an instantaneous event, like flipping a light switch. Instead, it's a gradual process that could unfold over hundreds or even thousands of years. During this extended transition period, the Earth's magnetic field would weaken dramatically. Its strength could plummet to as little as 10% of its current protective level. This significant weakening would leave our planet far more vulnerable to the constant bombardment of solar radiation. The protective shield would become porous, allowing more energetic particles to reach closer to the surface. One fascinating, though potentially concerning, consequence would be the appearance of auroras in unusual locations. These beautiful light displays, typically confined to polar regions, could become visible much closer to the equator. More critically, a weakened field poses substantial risks to our modern infrastructure, including satellites, astronauts, and global communication systems. The implications of a weakened magnetic field for our technology would be profound. Satellites, which are crucial for navigation, communication, and weather forecasting, would be exposed to higher levels of radiation. This could lead to malfunctions, premature aging, or even complete failure, causing them to burn up faster. On Earth's surface, power grids would face an increased threat from geomagnetic storms. These storms, caused by solar particles interacting with the weakened field, could induce massive currents in power lines, leading to widespread blackouts. Air travel, particularly routes near the poles, would become significantly more hazardous due to elevated radiation levels, posing risks to both passengers and crew. Beyond technology, the natural world would also feel the effects. Many migratory animals, such as birds, whales, and sea turtles, rely on Earth's magnetic field for navigation. A reversal could disorient them, disrupting their ancient migratory patterns and potentially impacting their survival. Ecosystems might struggle to adapt to these changes, leading to unforeseen consequences. For humans, long-term exposure to increased radiation could lead to a rise in cancer rates and other health issues. Furthermore, sensitive electronics worldwide, from personal devices to critical infrastructure, could be damaged by increased solar particle flux. A prolonged period with a significantly weakened magnetic field could have even more far-reaching consequences. Scientists often look to Mars as a cautionary tale. It once had a magnetic field, but its loss led to the stripping away of its atmosphere by the solar wind. While Earth's thick atmosphere would offer substantial initial protection, the long-term effects are a concern. The continuous bombardment of solar radiation would undoubtedly damage satellites and space stations, making space exploration and operations incredibly challenging. Even surface electronic systems, including computers and communication networks, would be more susceptible to disruption and damage. This could lead to a global communication collapse, severely impacting our interconnected world. The cumulative effect of atmospheric erosion, even if slow, could alter our climate and environment over millennia. While Earth's atmosphere is robust, a persistent lack of magnetic protection would test its resilience. Understanding these long-term consequences is crucial for preparing for such an event. Despite the daunting challenges, humanity would almost certainly survive a magnetic field reversal. Life on Earth has endured countless such events throughout its history, and our species is remarkably adaptable. However, significant adaptation would be crucial for our civilization to thrive in a new magnetic environment. Engineers and scientists would need to develop radiation-hardened satellites and spacecraft capable of withstanding increased solar radiation. Power grids would require substantial upgrades and improved protection measures to mitigate the risk of widespread blackouts. Innovative solutions such as the potential creation of artificial magnetic shields or plasma domes for critical infrastructure might even be explored. The history of life on Earth is a testament to its incredible resilience and capacity to adapt to profound environmental changes. While a magnetic reversal would undoubtedly be a transformative event, it would also spur unprecedented innovation and collaboration. Humanity's ingenuity and determination would be put to the test, but our ability to overcome adversity suggests we would find ways to adapt and continue our journey on this remarkable planet. If you enjoyed this video, don't forget to subscribe for more mind-bending science stories every week.